Hello students, I am Seema Bakhtar and I will be guiding you through the concept of Mohr circle, a critical topic for GATE and GSI exam. So, today we will learn what is the Mohr circle. Mohr circle is a graphical tool used to understand stress and strain transformation in a material. It's especially helpful for visualizing how stress on different planes relate to each other. In simple terms, Mohr circle helps you to find out how a material or object will respond when focuses are applied in different directions. We start with a known set of stresses like normal and shear stresses acting on a point on their then use Mohr circles to find stresses on the plane other than passing through that point. Key points we will cover: understanding stress element. This include normal stresses in acting perpendicular to surface and shear stresses acting parallel to the surfaces. Constructing the circle, we will draw the circle based on the stress value provided step by step to find the principal stresses and maximum shear stresses. Using the circle for transformation, we will see how Mohr circle makes it easy to find stress value at different angles without complex calculation. My goal is to make the topic clear and practical so that you will feel confident using Mohr circle in problem solving. Let's make it straightforward and rewarding. So, start with this. Before starting the Mohr circle, I want to clear some things. In geology, and or in the topic of the Mohr circle, the positive sign has been taken for the compression, that is the stress compression. It means it is stress is apply inner side, but the negative sign is taken for the tension in the Mohr circle. So stress is outside, then this is the use for the tension. Okay, let's start. Now let's start the Mohr circle. Now we will make a plane for this. Don't be laugh, my drawing is not so good. Okay, this is a okay, sorry, I have to make it in a middle. Now this is a plane for Mohr circle diagram. Now we will distribute the this stress on this. Now take a plane, this plane is taken from this block. Okay, uh, this is the sigma 1 and this is the sigma 3. We know that sigma 1 is greater than sigma 2 is greater than sigma 3. Okay, now stress is applied. Suppose that this plane is A1 and this plane is A3, and give its name A, B, D and C. Then draw a diagonal line, and this angle is the theta. Suppose that, then this angle must be a theta. Simple school mathematics. Now we will divide this sigma 1 in two components. Resolve this one. This is your sigma 1 and this is your sigma s and this is your sigma n. This is the shear stress, this is your normal stress. This is the resolution of the stress. So this will is the sigma s and this will is your sigma n. Okay, now here the sigma 3 is already applied, so the theta is this, then this is angle is the theta, and this angle is your, because this is your 90 degree, then this angle is a 90 minus theta. Okay, and this is your perpendicular resolution. So this angle is your, because this is already 90 and here the theta, then this angle is here 90 minus theta. Okay, this is the stress resolution. Now we will write the some formula and we will see from this plane. Okay, now simply sigma 1 is equal to F by A1, F1 by A1, because stress is nothing but a force, you can say for unique so stress is divided by the, and this on plane 1, so this is written as this. And when we will write this one, A1 is equal to A cos theta. Okay, A cos theta, A1 is equal to A cos theta. If you will take the respect to this, then this plane is A1, and so cos theta is equal to hypotenuse upon this perpendicular distance upon hypotenuse. So hypotenuse is AC, so nothing but this one is A and this is the cos theta. So this one, so and this is your sigma 1, that's one is the sigma 1, perpendicular distance is sigma 1. So put this value in this, so F1 is equal to sigma 1 A1. This is the equation. So F1 is equal to sigma 1 A cos theta. This is the equation number 1. So we will remove all things. So here written is F1 is equal to sigma 1 A cos theta. This is the equation 1. And now similarly for here this is the F1 force. Now here this sigma 3 on plane 3, this is the F3. So when you will apply the same trigonometry, then F3 is equal to sigma 3. This one is the A sin theta. Similarly you can see when you will these things, then this will be made. Similarly sigma 3 is equal to F3 upon A3 on plane 3. So A3 is equal to A sin theta, and put this in value and you will get to these things. Now this is equation 1 and equation 2. Now And what is the F1? When Fn is your, what is this? Fn is nothing but your combination of F1 and F3. This is your what is this? This is your one is the normal component and one is the shear component. So this is equal to this one. Then so F1 is equal to F1 cos theta plus F3 cos 90 minus theta. Okay, this is the F1 in case of the force. Okay, I'm not talking about these things there. Now we will put the value of the F1 and F3, then this will be making the sense. Now using equation 1 and equation 2, because force is perpendicular force, na, this one, how this will look like. This is your Fn and this is your F1 and this is your F3. So F1 is equal to nothing but this one, and in the case of this, because this is your 90 minus theta, so we are taking here the cos 90 minus theta in case of this. So put this value for F1 and F3 from equation number 1 and equation number 2. Sigma 1 a cos theta, and this is the your cos square theta, and plus sigma 3, because cos 90 minus theta is what is this, sin theta. Then this will be the sigma 3 a sin square theta. Now from equation 1 and 2 put the value of F1 and F2. Now equation 1 and 2 put the value of F1 and F2. We have already put this value, so don't worry. Now so we will put here the value of the Fn. So Fn is a what? This is sigma, and n is equal to Fn by a. Then put the value of the Fn. Then what will this? This will the a sigma n. Then a cut and sigma n. Then finally you can write here sigma n is equal to sigma 1 and plus sigma 1 cos square theta plus sigma 3 sin square theta. This is the equation you have got. Let's its name it's sigma 3, equation number 3. Now we have calculated is this is your sigma n, that is the normal stress, and this is nothing but is sigma 1 cos square theta plus sigma 3 sin square theta. We have seen, mark it, this is the equation number 3. Now we will calculate the same fashion for sigma s. Now we will calculate sigma s. So we will draw a figure, a plane. Okay, this is a plane. Here your sigma 1 is a stress, and this is your sigma 3 is less stress. Now diagonally crack has developed. Now this angle is your theta, and this angle is your also a theta. So when force F1 is applied this way and F3 is this way, this is your F1, this is your F3. Okay, and this is your Fn. So we will calculate the sigma Fs and put the from this Fs we will calculate the shear stress. Okay. Now one thing you, and this is your shear stress. Okay, one thing you know, for dextral side you have to take the negative, and sinistral you have to take the positive. Okay. Now in a same way, then for fs, what will this is your fs. So in a same way, fs is equal to minus f1 sine theta plus f3 cos theta. Now put the value of f1 and f3 from equation 1 and 2, which we have calculated in first time in a starting. Okay, so fs is equal to minus f1 sine theta plus f3 cos theta, and this is the same way, this is the equation. Put the value of this, and in this equation we will put the value this from equation 1, and 2, put the value of f1 and f2. Okay. So when we will put, then this fs will be this minus sigma 1 a cos theta sine theta plus sigma 3 this will be a cos theta and sine theta. Okay. Now this has been drawn, and no, if you have remember, we know sine 2 theta is equal to 2 sine theta into cos theta. You know this formula. If you know, then this will be very actually the Mohr circle diagram with this stress diagram, which we have applied on a block and a block's plane. Then I want to show this stress act as a circle. Then we have to finally draw a circle equation. That's why we will do the lots of the things, and that's why Mohr as German scientist, I think, or French scientist, I don't know, famous for this. He show the Mohr is a act as a circle. Okay. Now come to the this another points. If you know this formula, then take some different color, and then equation this will become fs, take mark it the 4. Okay, fs is equal to take the value, put the value in this one, when the value sine 2 theta, put this value sigma 1 a sine 2 theta upon 2 and plus sigma 3 a sine 2 theta upon 2. Now sigma s is equal to fs upon a. Remove these things. this one, what will happen now? Sigma s is equal to fs upon a. Okay, you know well this one, and we have derived this equation. Okay, now put this value fs value in this equation. Then what will happen? This is your sigma, what is this, sigma s, and this is a and is equal to this one. Then from this cut this value, then finally you will find the minus sigma 1 sine 2 theta upon 2 plus sigma 3 sine 2 theta upon, this is a sigma 3 upon 2. Then sigma s is equal to sigma 1 minus sigma 3, because how is it in this will be possible, sigma this can be possible because here minus, so by 2, and this is your sine 2 theta, take the common. Okay, and this equation has been derived. Now you know well in from your school knowledge, cos 2 theta is equal to cos square theta minus sine square theta. Then cos 2 theta is equal to 2 cos square theta minus 1, and then cos square theta is equal to cos 2 theta plus 1, because here going this side, cos 2 theta plus 1 upon 2, and this will be the, finally you can write here this way. You know, if you know well, this is your cos square theta, then what will you written here? You can write these things 1 minus cos 2 theta upon 2 is equal to let me explain more these things. Okay, you know well here from here. Then cos 2 theta plus 1, you can write these things you can write these things cos 2 theta, and go here these things, what will happen? 2 cos square theta minus 1, then 2 cos square theta minus 1, you can write here the 1 minus 2 sine 2 theta, thus just previous trigonometry formula. Then finally sine square theta, sine square theta is equal to, this is a sorry, this is a 1 minus sine square theta, this sine square theta is equal to 1 minus cos 2 theta upon 2. Okay, this is a simple trigonometry equation. Now this has been derived, and you have written sine square theta and this, then equation 3 becomes this way. Now come to the sigma 3 equation number 3. If you have remember the equation number 3 is, let's just remove these things. Let's remove just these things, and you know the equation 3 is we have derived sigma n is equal to sigma 1 cos square theta plus sigma 3 sine square theta. This is the equation number 3. Now we will use this in equation number 3. Then equation number 3 will, and sigma s we have already derived, so don't worry about this. Then sigma n is equal to sigma 1 by 2 cos 2 theta plus 1, because cos 2 theta is equal to cos square theta minus 1, and sigma 3 by 2, this one is the 1 minus what will this this is equal to cos 2 theta by 2 sigma 3. Okay, now equation 6 become sigma n, this is sigma n is equal to sigma 1 minus sigma 3 upon 2, and this is the cos 2 theta plus sigma 1 plus sigma 3 by 2. So if this is the equation number 7, and because we have take the common of this sigma 1 minus 3, so after then come to this, what is the equation of the circle? This is the your, if you taking, this is your a circle and its radius is suppose that this is your diameter, and this is your x and y, and this distance is your r. Then radius of the circle is x square, equation of the circle is x square plus r square, this is one. So we have to take this in this form. Now so what will you do? Take this sigma n from equation 7, sigma n minus sigma 1 plus 3 by 2, and this will be your is equal to sigma 1 minus sigma 3 by 2, and this is your cos 2 theta. Okay, and take the bracket and keep the square both side. Okay, now because we have to take this in the form of the circle, this is your equation number 9, because just over there this is equation 8. So now adding equation 8 and 9, and what is the 8? Equation number 8 is what? 8 is your this is the equation 8, 9 this one. This is for the sigma s. Now sigma s, if you have remember, we have calculated minus, because here the minus, you just see sigma 1 minus 3 by 2, take bracket and keep the big bracket, square sin square 2 theta. This is the equation number 9. Now adding equation 9 and 8, just remove these things. Adding equation number 8 and 9, then what will happen? Adding equation number 8 and 9, then sigma n minus sigma 1 plus sigma 3 by 2 whole square plus sigma square s, and now adding this 8 and 9, this is 8 and this is the 9. Just here, this is the cos square theta sin square, then comma, take the value comma, sigma square is equal to cos square theta plus sin square theta, and this is the 2 theta, because here the 2 theta, this is 2 theta, and here this is sigma 1 minus sigma 3 by 2 ka whole square. Okay, Now take sigma n minus sigma 1 plus sigma 3 by 2 square plus sigma s square sigma 1 minus 3 by 2 का whole square. This is the r your this value, and this is your x square plus y square. So this is the equation of the circle. That's why this is called a Mohr circle diagram. Now we will see some numerical on this. Okay.